Hello students, we will start with modern electronic communication. Okay, so in this chapter we will try to understand different modes of communication, different instruments used for communication. So that is what we will there. The first topic is elements of communication system. Elements of communication system. So basically when we are trying to understand modern electronic communication, so basic जो device है, that is a transmitter represented by TX and a receiver represented by RX. This is a transmitter and this is a receiver. Basically what we mean by communication is transfer of information from one point to another. Okay, so what type of informations are available? Information can be text, video, voice, image. These are nothing but the information. Okay, this information has to be transferred from one point to another. Okay, so and of course it should be retrieved back in the same form: text, video, voice, or an image. Okay, so this is your information. This is information. Now the most important element of a communication system is the channel or the medium through which the information is transmitted. Okay, so this is channel or medium is the most important element in your electronic elements of communication system. Okay, so there are three mediums through which information is transferred. Of course you know that the first one is wired communication. Okay, wired communication, that means a wire will be connected between 2 points and information will be transferred through the wire. Okay, the second one is radio communication. When we say radio communication, that means any information transmitted from one point to another point through space is called as radio communication, because the signals which we use to transmit are radio signals. Okay, radio frequency signals. So therefore the type of communication is called as radio communication. So here we don't need wire, we can transmit the information through space. So that is you can easily understood that mobile communication. So mobile communication, there is no wire connected between one mobile to another mobile. We communicate the information through space. So that is space communication, or we can call it as radio communication. Whereas wired communication, and a very good example of this is your cable TV. Cable TV, the information is transmitted from the cable service provider to your home through a wire, coaxial cable. So that is wired communication. Telephone lines, the landline, all these communications is done by information transmitted through wire. And the last one and the most effective one is optic fiber cable communication. You must have heard about this optic fiber cable. When I say optic fiber, that means here of course it will be a length of wire, optic fiber cable, and information in this wire is transferred in the form of light. Okay, so the information has to be converted into light, and then the information is transmitted through the cable, and it can be received at the other end. So this when I say this is more effective, because large amount of information can be transmitted over long a long distance, so that is, and at a very high speed. So that is why I said it is more effective as compared to the other two. Okay, so information will go to the channel. As I said, in channel will be important. Now why I said that channel or medium is more important, because first we have to decide in an element of communication design what type of channel or medium we are using. Suppose we are using modern communication, wired communication, what we have to do is all this information has to be converted into electrical impulses, that means electrical signals, and then transmitted through wired communication to the receiver. And of course, what the transmitter will do, it will convert electronic signals into electrical signals, and then this text, video, voice, images, all this information to electrical signal, and then at receiver end the receiver will convert electrical signals back to the information. So we select the transmitter and receiver on the basis of channel or medium which we are going to use. So that is what is the most important element. Next is radio communication. So in radio communication, when the radio communication is used, that means information is transmitted through space, the information has to be converted into electromagnetic waves, which is called as radio waves. So all this information will be converted by the transmitter into radio signals, that is electromagnetic waves. Through medium it will be traveling to receiver. Receiver will receive the information, convert the electromagnetic wave back to the information. Okay, and the last one is optic fiber cable. So in optic fiber cable, of course, if you are using optic fiber cable as the medium, all this information will be converted into light first, and then the information will be transmitted through the optic fiber cable to the receiver. The light received by the information received in the form of light by the receiver will convert it back into text, video, voice or image. So basically transmitter and receiver will be we will be selecting a transmitter and receiver on the basis of the channel or the medium which we are going to use. And another very important element of this communication system is noise. That is, in electronic terms, it is called as disturbance. Okay, there are large amount of probability because of which there will be disturbance when the information will be transmitted from one end to another end through a medium. And I said optic fiber cables are effective as compared to wired and radio communication, because the noise level or the disturbance which occurs is less in case of optic fiber cable as compared to wired communication and radio communication. I hope you have understood. The next topic is types of communication system. Okay, so types of communication system. Types of communication system is in that the first one is one way and two way communication system. One way or two way communication system. So this is the types of the one way and two way communications are further classified as simplex, half duplex and full duplex. Okay, half duplex, simplex, half duplex and full duplex. So simplex means communication in only one direction. Okay, communication in only one direction. That means an example of that is radio broadcasting. You listen to songs on your mobile phone, right, through radio channels. There are several channels. So information is transmitted from the radio channel to you. You cannot transfer back information to the radio channel. Similarly, TV broadcasting. In TV broadcasting, all these signals will come from the broadcaster to you. You cannot transfer information to the broadcaster. So information is traveling only in one direction. That type of communication is called as simplex. Next is half duplex. Communication in both direction, but one at a time. Of course, the example of this communication in both direction but one at a time is walkie-talkie. The police persons will have walkie-talkie. What they do is there will be a device like these. Two devices will be there over which the communication, one antenna will be there and one manual button is there. Okay, so it acts as both transmitter as well as receiver. But when the first device is talking, that means it is acting only as transmitter. The second device over which the communication is carried out has to listen till then. So at this point it is transmitting, the second device is listening, that means it is receiving the data, right? So communication is possible only in one direction at a time. Now once he has done talking, what he will do is he will change the manual button from transmitter to receiver. That means it is going to accept the signal now. Similarly, the second, the listener will now become a talker. So it will change manually. It will change the setting to transmitter. So information will be now transmitting from the second device to the first device. अब ये listener हो गया और ये talker हो गया, right? So the information will be transmitted in both the direction, one at a time. You must have seen, of course, you must have seen in movies that when if they are talking in a walkie-talkie, at the end of every conversation they say over and out. That means at that point the person who was talking will change manually to receiver, and the person who is listening should change himself from listener to talker. That means now he will transmit the signal and the first person will receive. Okay, so communication in both direction but one at a time. Full duplex means communication in both direction simultaneously. Of course, your mobile communication. Okay, so this is communication in both directions simultaneously. Example is your mobile communication. Okay, the second one is analog and digital communication. Analog and digital communication. If the information is transmitted as continuously varying signal, it is called as analog. And if the information is converted into digital means binary information which has only discrete states 0 and 1. So if they are converted into digital and then transmitted, that type of communication is called as digital communication. So digital communication is much better because of its low noise value as compared to analog communication. So this is the second type of communication, analog. So if analog means continuously varying signal, if it is transmitted directly through the medium, it will be called as analog communication. Or when it is converted in analog signals are converted into digital, that means binary information, and then this binary information transmitted from one point to another, that type of communication is called as digital communication. Okay, so this is the second part. And the third part is called as baseband or modulated. Baseband or modulated communication. Baseband communication where original signals are directly transferred through medium. And modulated communication, where original signal is modified and then transferred over the medium, will be called as modulated communication. I will give you examples of both. Baseband communication, you know, a LAN system. For example, there is an internet cafe and 10 computers are connected, okay, and these 10 computers are connected to one single printer. You go to internet cafe to take printout sometimes, right? So what you do is, irrespective of any computer you are sitting, you can give print command to the printer. That means printer is connected, that means information is communicated from several devices to the printer. In that case, LAN system, original information is transmitted from one point to another. Of course, we will try to understand this LAN, WAN, MAN in further classes, but at present that type of network where the information is original form, information in original form is directly transmitted through the medium from one point to another is called as baseband communication. And the next one is modulated communication. As I told you, original audio signals cannot be transmitted through space. Therefore, all these radio signals, radio channels which we listen to has the frequency as 93.5 megahertz, 91.1 megahertz, 92.5 megahertz. All these frequencies are in megahertz. Megahertz frequencies are not audible frequency. They are just a carrier frequency, because original signal cannot be, that means original audio or voice signal cannot be communicated over a large distance. For example, if you are standing on your terrace and if you shout or if you speak something, what happens? The voice will reach maybe 100 meters, 200 meters to the building in front of you. But what happens to the sound signal which you have produced at around 1 kilometer? Of course, you cannot hear. 1 kilometer, after 1 kilometer, you cannot hear your, nobody can hear your voice. That means original voice signal, which is in the range of 30 hertz to 20 hertz to 20 kilohertz, that frequency cannot be directly transmitted into the medium because it is not going to travel a long distance. For that, what we have to do is the original signal and the high frequency signal which can travel a long distance, these two frequency has to be mixed. So original audio signal and this 93.5 megahertz. So 93.5 megahertz is the carrier frequency which will carry the original signal to long distance, and that process is called as modulation. And in your phone you have a demodulator which segregates these two at the receiver end. That means the original signal and the carrier frequency. It removes the carrier frequency, takes the original signal, amplifies it and give it to the speaker so that you can listen to audio signal at 93.5 megahertz, which is not a audio frequency. So we have to demodulate the carrier frequency, original signal will be taken and then we can use it. So that is where we are changing the characteristics of the original signal before being transmitted. That type of communication is called as modulated communication. So this is type of communication system. I hope you have understood. Hello students, next we will try to understand a concept called as modulation. I gave you a brief idea in the previous video of types of communication. So the last type was baseband and modulated communication, modulation communication. So in baseband, original signal is directly transmitted into space, and in modulation the characteristics of the signal is changed and then it is transmitted. That is what is called as modulation. I also gave you an example. We will elaborate that same thing in this topic. Okay, so the topic which we will try to understand is modulation. Okay, first we should understand why modulation is necessary, why you need to change the characteristics of the signal before transmitting it into the space or through wired communication, whatever it is. Okay, so first we have to understand the necessity of modulation. So that is what we will going to understand, necessity of modulation. Okay, so there are three points which we will discuss under the heading necessity of modulation. The first being, as I told you, if you suppose audio signal has to be transmitted. Let us take an example of an audio signal being transmitted. Okay, so if an audio signal has to be transmitted, just for an example, if you are standing on your terrace and if you speak out loudly, how far this signal will be transmitted? The signal will at the most it will reach, say, 100 meters or 200 meters or 300 meters, right? But what happens to the signal strength after 1 kilometer, after traveling a distance of 1 kilometer? Of course, nobody standing at 1 kilometer will hear your voice, right? Because the strength of the signal will keep on decreasing with the distance it travels, because the energy associated with an audio signal is a low frequency signal which is within the range of 20 hertz to 20 kilohertz. Okay, 20 hertz to 20 kilohertz. So these are very low frequency audio frequency. So this low frequency signal, the energy associated with the signal is very less, and if the energy associated with the signal is very less will be the distance traveled by the signal. Therefore you cannot transfer original signal directly into the medium, that is space. Of course, if you are talking about space, you cannot directly transmit the signal into the space. That means there you need modulation. So the first point under the heading of necessity modulation is poor transmission. Okay, so what we said is energy associated with the signal is directly proportional to the frequency. Okay, so if frequency is less, energy is less, distance traveled will be less. So of course, if you have to transmit your audio frequency at a long distance, you need to change the characteristics, you need to modulate, and that is why modulation is necessary. So that was the first point. Okay, poor transmission. Second is interference. Just imagine that all radio channels are transmitting audio frequency, original audio frequency, directly into the medium. You just imagine the scenario. There are so many radio channels, and 93.5 है, 91.1 है, 92.94 point something, there बहुत सारे रेडियो चैनल्स है, और इमेजिन करो कि वो सभी चैनल एक ही फ्रीक्वेंसी ट्रांसमिट कर रहे हैं, which is within the range of, or suppose audio frequency original signal directly transmit कर रहा है within the range of 20 hertz to 20 kilohertz, and almost all the frequency will belong to a same band, same frequency band. So what will happen is they won't travel individually, instead they will mix with each other. That is what is called as interference. That means when we say interference, same frequency signal cannot be directly transmitted into space. same frequency signal cannot be directly transmitted into the medium. Of course, we are talking about space, so it cannot be transmitted. So radio frequency cannot be transmitted directly, okay, which has a frequency range of 20 hertz to 20 kilohertz, because they will interfere with each other, and what we will get is nothing but noise or disturbance if you relate it to the electronics, okay. And the third is the most important, is height of antenna. Of course, any electromagnetic signal which you transmit, to receive that electromagnetic signal you need an antenna. So we are talking about height of antenna. So height of antenna is lambda by 2. Lambda means wavelength, okay. So what is wavelength? Wavelength is your speed of your signal transmitted, that is 3 into 10 to the power 8 meter per second, speed upon frequency, right? So 3 into 10 to the power 8, and frequency, of course, if you are talking about original audio frequency, let us take it the maximum value, that is 20 kilohertz. So 20 into 10 to the power 3, this can be written as 3 into 10 to the power 8 upon 2 into 10 to the power 4. This is 1.5 into 10 to the power 4, or I can say it is 15 into 10 to the power 3. So 15 kilometer, okay. So that is the length, wavelength, lambda. And what we said, what should be the height of the antenna if you are transmitting original signal directly into the space? To receive that, the height of the antenna should be lambda by 2. And what is lambda? Lambda is 15 kilometers. So what is lambda by 2? It will be 7.5 kilometer. Is it feasible to have an antenna whose height is 7.5 kilometer? Just imagine that all the radio channels are transmitting original signal, and say without interference it has reached to your mobile phone. Now the mobile phone, to catch that particular frequency, should have an height of 7.5 kilometer. Is it feasible? Of course not. So for all these three reasons, it is very important that modulation should be done, okay. So modulation, if somebody asks you to define modulation, it is a process in which characteristic of high frequency signal is changed in accordance with the original signal. It is a process. Of course, in generalized term we say it is a process of mixing two signals, but what we are doing is, as I told you in that example, that if you want to transmit audio signal, you have to mix that audio signal with a high frequency signal. So 93.5 megahertz is the carrier frequency, and you have to mix the original frequency with the carrier frequency. The process will be called as modulation, right? If you remember, it is called as 93.5 megahertz FM. FM stands for frequency modulation. We will try to understand what exactly we mean by frequency modulation in types of modulation. Now you have to understand that before transmitting, the original signal and the high frequency carrier wave is mixed. The way in which they are mixed and the characteristics is changed, on the basis of that we will classify modulation in different types, okay. So that is what we have been. It is a process in which characteristics of a high frequency wave is changed in accordance with the original signal. That is called as modulation. The three types of modulation which we will try to understand is amplitude modulation, second frequency modulation, and third phase modulation. Okay, there are a lot of mathematics which has been specified, the number of derivations which has been specified in the book. It is given in the book for these topics: amplitude modulation, frequency modulation, and phase modulation. It is not at all necessary, never been asked in the exam, and this year it has been omitted, that the mathematical part. You just have to understand the basics of what exactly we mean by amplitude modulation, frequency modulation, and phase modulation. Of course, we need to understand the diagram. Okay, we have to understand, we have to represent it diagrammatically, we have to understand it in the form of definition. So these two things are very important for these three topics. Okay, so I hope you have understood the basics of modulation. In the next part, we will try to understand the different types of modulation with its definition and diagrammatical read. Next, we will try to understand types of modulation. Okay, so types of modulation. Under this heading, the first one is amplitude modulation. Okay, see, we have the definition of, generalized definition of modulation. It is a process in which characteristic of high frequency signal is changed in accordance with the original signal. So high frequency signal will be a carrier wave, original signal will be an audio frequency. Now, what characteristics of high frequency carrier wave is changed, and that specifies the name of that particular modulation. So from the name itself, we can understand that we are going to change the amplitude of the high frequency signal corresponds to, in accordance with the original signal. Okay, so what we will do is, I will write the definition of amplitude modulation. In this modulation, amplitude of high frequency carrier wave is changed in accordance with the original signal, keeping its frequency constant. Okay, so in amplitude modulation, what we are going to do is, we will change the amplitude of the high frequency signal, high frequency carrier wave, in accordance with the original signal, but keeping its frequency constant. So let us try to understand by graphical representation. Okay, so see, this is the original signal, a low frequency audio signal. Okay, low frequency audio signal. This is time period, and this is the amplitude. We specify it as V. Okay, so this is your original signal. Okay, and then we have a high frequency carrier wave. Okay, a high frequency carrier wave, and we have to modulate this two, that is mix these two signals. This is time period, this is V. Okay, so this is high frequency carrier wave. Okay, high frequency carrier wave, and then we have to modulate. And what is the modulation process? We have to change the amplitude of the high frequency carrier wave in accordance with the original signal. Okay, so the modulated wave for amplitude modulation will look like this. Okay, see, the waveform will look, the modulated waveform will look like this. We are keeping the frequency constant, but we are changing the amplitude. Okay, we are changing the amplitude. Now see, let us represent this as different points: A, B, C, D, E, F, and this is G. Okay, what you can see from the diagram is at A, C, E, G, at this point the amplitude is 0. Okay, so if the amplitude is 0, the amplitude for carrier frequency should be kept same. Okay, at B and F it is at positive peak, so the amplitude has to be increased. At D it is at negative peak. To represent negative peak, the amplitude has to be decreased. So that is what we have done. So this is the point A, okay, where the amplitude of the high frequency carrier wave is remain as it is. This is the point at which the amplitude increases. This point is B, okay, positive peak. Again the amplitude is constant. This is point C. Then the amplitude starts decreasing. Okay, so this is the point. This is the point where you get this is B, this is C, this is D, again E, this is F, and this is G. Okay, so this is how you change the amplitude of the high frequency carrier wave in accordance with the signal, but we keep the frequency constant. Okay, so this is called as modulated wave. So this is amplitude modulation. In this modulation, amplitude of the high frequency carrier wave is changed in accordance with the original signal, keeping its frequency constant. You just have to remember this definition and you have to represent it graphically. Okay, so this is amplitude modulation. Let us now try to understand the next type of modulation, that is frequency modulation. Okay, so that is what is called as FM, frequency modulation. So the second type is frequency modulation. So now you can guess, okay, what exactly we mean by frequency modulation, what we are going to change now. What we have to change? Characteristics of the high frequency carrier wave in accordance with the original signal. So what characteristics of high frequency carrier wave we are going to change? We will now change the frequency of the high frequency carrier wave in accordance with the original signal, keeping its amplitude constant. So that's it. Okay, so in this modulation, frequency of high frequency carrier wave is changed in accordance with the original signal, keeping its amplitude constant. Okay, so that is the definition of frequency modulation. Again, we will represent it by graphically. So say this is the low frequency, this is the low frequency signal, your original signal. Say this is your high frequency carrier wave, which has to be modulated in accordance with the original signal, and the third one of course will be the modulated wave. Okay, so in modulated wave, again let this point be A, this is B, this is C, this is D, this is E, this is F, and this is G. So at point A, C, E, G, the amplitude is 0, so the frequency remains same. At B and F, positive peak, the frequency increases. When you say frequency increases, F is equal to 1 upon T, right? They are inversely proportional. F is equal to 1 upon T, T is equal to 1 upon F. If frequency increases, time period decreases. So we have to, when we say frequency increases, we will show by the narrow waveforms. That means time period decreases. And at point D, that is at negative peak, the negative peak, we have to decrease the frequency. That means time period will increase. We have to indicate broad signals. Okay, so that is what we will do here. So at A, the frequency remains same, and when it reaches B, we have to represent it by narrow pulse. Then at C, the frequency again becomes same. Then at D, it will be shown as broad pulse. Then at E, again the original frequency. Then at F, again the frequency should be increases, time period will be decreased, and then at G it will be its original frequency. So we have kept the amplitude constant. At A, the frequency is same. At B, frequency increases. C, again it becomes same. At D, the frequency is decreased, that means time period will increase. At E, again it becomes constant. E, F, the frequency will again increases because of the positive peak, and at G it will again come to constant. So this is your high frequency carrier wave, and this is the modulated wave. So this is frequency modulation. In this modulation, frequency of the high frequency carrier wave is changed in accordance with the original signal, keeping its amplitude constant, and this is the graphical representation of frequency modulation. The third one under the heading types of modulation is phase modulation. Okay, so now you have already got the idea. So what we are going to change is we will change the phase of the high frequency carrier wave in accordance with the original signal, keeping it amplitude and frequency both constant. Okay, so any positive change will represented by lagging signal, and any negative waveform will represented by leading signal. Okay, so I will just explain you what exactly mean by lagging and leading. Okay, in this modulation, phase of high frequency carrier wave is changed in accordance with the original signal, keeping its amplitude and frequency constant. Okay, so this is the basic definition for phase modulation. And say graphical representation. So this is a original signal, low frequency, here original signal, low frequency signal, low frequency original, low frequency signal. Okay, this is V, that is amplitude with respect to time. Okay, this is the high frequency carrier wave 1, Okay, so this is your high frequency carrier wave, and then the modulated wave. Okay, so the modulated wave will be like this. Okay, we have to keep the amplitude and frequency constant, but when we go from positive to negative, the phase should lag, and when we go from negative to positive, the phase should lead. I will just let you know what exactly you mean by that. We are keeping the amplitude and frequency constant. We are just changing the phase. Okay, this is V. So here we have changed the phase. This point we have changed the phase. Here it is lagging. Okay, so this is lagging phase shift. I have explained you things with respect to the phase shift in CRO. I have explained you what exactly we mean by leading phase shift and lagging phase shift. Leading by 90 degree, lagging by 90 degree. So this is lagging and this is leading. Here we are going from positive to negative, so it is lagging. Here we are going from negative to positive, so it is leading phase shift. So we are changing the phase shift, but we keep the amplitude and frequency constant. So that type of modulation is called as phase modulation. So in this topic, under the heading modulation and types of modulation, you need to remember the definition of modulation, the necessity of modulation, and the type of modulation, just the definition and the graphical representation. So this entire topic is covered for your board exam. Okay, so this is all about modulation in modern electronic communication. I hope you have understood. So now if somebody asked you what exactly 93.5 megahertz, so 93.5 megahertz is nothing but the carrier wave. It's not the original signal, it's the carrier wave where the characteristics of the original wave has been mixed, and when it reaches to you, you demodulate the signal. Okay, demodulate the signal. You separate the high frequency carrier wave and the original signal. Then we don't use the high frequency carrier wave, you just use the original signal, give it to the amplifier to amplify, and then it will be given to the speaker so that you can listen to the original signal. So now I think the idea about modulation is clear to you. Thank you.